We're starting a new chapter, chapter 3 today, and 3.1 is called Algebraic Expressions. There's a few terms that I'd like you to write down, so if you would, pull out your red pen and fill in these blanks. The first thing you wrote down was terms. These are the different parts of the expression that are being added or subtracted together. So whatever it is, it's basically just the different parts of the original problem in the expression. Next up is a variable term. A term with a variable in it. Can anyone raise your hand and give me a guess of what you think a variable is? Very good. It's a letter. In math, the two most commonly used letters are X and Y. However, it can be any letter out of the entire alphabet. So you can see here, we've got some examples. X, 4x, 3x, x squared, 5x squared, and 7x squared. Those are variable terms because they have a variable or they have a letter in it. Everyone say variable? Variable. Letter. Letter. The next one is coefficient. This is a tricky word. Repeat after me. Coefficient. Coefficient. Read to me what a coefficient is. So if you look at, let's say, this example here in the middle, 3x, what's the number in 3x? 3. It is 3. If I were to say 10x, what's the number? 10. If I was to say 7x squared, what's the number? 7. Very good. So the coefficient is just the number part of the variable term. Next word is constant. Read to me what a constant is. A number that stands alone. All right. So if I had something that says 5x plus 2, we know and understand that's my variable term. What's the number that's standing by itself? 2. 2. Now let's imagine instead that it said minus 2. What's my number that stands alone? 2. Not just 2. Negative 2. Very good. The next one is like terms. These are terms with the same variable that is raised to the same power. If you would, take your red pen for me, and I'd like you to circle these first 3 examples here. 2x squared, 4x squared, and 3x squared. If I was to say that they were in a family, that would be the x squared family. Now I want you to underline the 5 and the 6. Those are numbers that are standing alone. They're by themselves. Do you guys remember what that's called, a number that stands alone? A constant. Very good. Now there's still something else here that I've written in green that's in the x family. What are the 2 examples of the x family? The 8x and the 10x. Let's circle those. So each of these, I say they're in the same family, but that means they are like terms. The first set we have here is the x squared family. Next we have the constant family, and then we have the x family. Those are considered like terms because they are like each other. And the last thing is simplest form means no like terms. For the next section, it asks us to identify the terms and like terms in the expression. But before that, you are writing something down in your red pen. Read me what that saying says. Every number has a sign, and that sign is directly in front of that number. This is something we talked a lot about in chapter 1 and chapter 2. Remember, if it looks like a minus sign in front of it, when you're subtracting a number, that is a negative number. So we're going to underline the things that look alike. If everyone would, please underline the 9x. Do this with your pencil. Is there anything else that looks like it's in the x family, class? The negative x. Thank you for saying negative. Now, looking at this one, how many x's are there that are negative x? 1. There's only 1. So I want you to write the imaginary or the understood 1. That tells me that's only 1 negative x. Now we've got a constant. Negative 2 is constant. Do you see any other constants that are there? 7. The 7. That's also a number that stands by itself. Remember, when you circle it or you underline it with the plus sign and the minus sign. Next, I want you to look at your terms at the top. Tell me again, what is a term? Read me the definition.
Parts of the expression being added or subtracted together.
Everybody, look at the top of your notes. Read me one more time. What does terms mean?
Parts of the expression being added or subtracted together.
So according to my original problem, the first thing that's being added or subtracted together was a 9x. Write this down. That's the first term. The next term is a negative 2. What's the next term reading from left to right? A plus 7. You could put the plus if you want, or you know it's understood. You don't have to. And the final one is a what?
Negative x.
Negative x. And you can put negative 1x or just plain old negative x. It means the same thing. So those are the terms. Now I want to know which ones are alike. We've already kind of done this up at the top by underlining the ones that are similar and circling the other ones that are similar or that are alike. The first one, 9x. What is similar or what is a like term with 9x? So you're going to write 9x and negative x. Those are in the same family. They are like terms. Okay, they're the x family. There's another set of like terms in there. They're my constants. What are they, Isaac?
Numbers that stand alone.
Okay, very good. So what are those numbers that stand alone in my original problem?
-2 and 7.
Very good. -2 and 7. And those are all my like terms. Now let's just continue to coefficients. Look up at the terms that we wrote down at the top, those vocab words, and everybody read to me, what is a coefficient?
The number part of a variable term.
The number part of a variable term. Remind me once again, what is a variable, class?
A term with
The letter. Okay, so we're looking for the letter, and we want to see if there's any numbers that are attached to our letters. What letter is in my original problem?
9.
Just the letter is the x's. Okay, what numbers are attached to those x's?
9 and 1.
9 and
1.
-1. Okay, and that's why we sometimes will put the 1 in there so that we understand that is a number that's attached to that letter. Next up is a constant. Go up to the top and read to me the definition of a constant.
A number that stands alone.
A number that stands alone. Hayden, what are my numbers that stand alone in problem A?
+7.
Very good. -2 and +7. So that is identifying those different things that we have. Today on your homework, when you come to it, you're going to need to identify just the terms and the like terms. Okay? So when you do your homework, you will, just like normal, you'll write the original problem, then you'll write out the word terms, write out the word like terms, and you'll identify what those are. Let's do another example that's similar to this. Every time we have something like this, we're going to underline and circle the like terms. So let's always start with underlining the very first one, -3x. Jalen, is there anything else that's in the x family that is a like term with -3x? Not just 5x, but
-5.
-5x. All right, now there are some constants there. Angeline, what are my constants? Excellent. +7 and +10. So now that we've underlined and circled, we're going to go ahead and identify what these are. The terms, remember, that's just all the numbers that are being added or subtracted together. What's the first term you see there, class?
-3x.
Write it down. And we're just reading from left to right what those terms are. What's the next term you see there? +7. The next one?
+10.
And the final one?
-5x.
Thank you again for saying -5. Very good job. Now we're going to bump down to the like terms. Is there anyone who feels like you could easily identify those like terms for me? Noah, what are the first like terms you see there?
-3x and -5x.
Excellent. Those are in my X family, so those are like terms. Noah, do you see anything else that's alike?
+7, +10.
Very good. The +7 and the +10. Now I'm going to move on to the next word. Repeat after me. Coefficients. All right, we don't have our terms right above us now, but does anyone remember a coefficient is the number part of a variable term? Say that one more time. The number part of a variable term. So you're just looking for what the letters are and seeing what numbers are attached to them. Einar, what are my coefficients? -3, and is there any other coefficients? Very good, -3 and -5. The final thing I want to do for problem B is to find my constants. Just the girls tell me, what is a constant?
The number that stands alone.
Everyone say it? A number that stands alone. Huang, what are my numbers that stand alone? +7 and +10 is correct. For this next part, I've got y² plus 5y minus 3y² plus y. Are there any other understood number ones that I should put in there? Yes. Which ones?
Y squared.
There's a couple of them, all right? The first one, don't say y2, but y², and the other one is that y that's at the end. Now, here's the deal. Y² is actually in a different family than the y family. They might be cousins or something like that, but they don't actually live in the same home. They are two separate families. So let's find the first family. That's the y² family. Is there anything else there in that family?
3y squared.
Not 3y squared.
Negative 3y.
Good job. Underline the negative 3y squared. Now, as I just said, the y's are not a part of the same family. They're not like terms with the y squared. So let's circle plus 5y. What else is a like term with plus 5y? Plus 1y. Now we are ready to identify these four things. First one, Isaac, can you tell me what the terms are in the original problem? Okay, not 1y2, but 1y squared. What's the next one?
3y squared.
5.
Negative 3y squared. 1y.
Very good. Now when you're writing this, you can put the 1 there if it helps you. You do not have to. That's up to you. Like terms. Who would like to do the like terms for me? Ava, go ahead. 1y squared. Very good. Those are in the y squared family. Is there anything else that's like terms?
Yes.
Which ones?
5y, the positive 5y, and the positive 1y.
Excellent. Very good. All right, let's see what you came up with. What are my coefficients? There should be 3 of them. Anyone want to help me with that? What do you think?
5, 3, and 1.
Excellent. 5, 3, negative 3, good job, and 1. Now, as you can see, there's a 1 there and a 1 there. You don't have to rewrite the 1, but that's why sometimes it's nice to put the understood 1 there so that we understand that is a 1 that's there. Finally, my constants, just the boys. What are the 2 constants? Are there any?
No.
There are none, so we're actually going to write none. It doesn't have to have a constant. If it had said something like plus 14, then this would be my constant. But there were no numbers that stood alone, so the answer is none. For section number 2, it asks us to simplify the expression. Can someone tell me what that word simplify kind of sounds like? That's exactly what I was going for, to go for make more simple. I want to simplify the expression or make it more simple. In order to simplify something or to make it more simple, we're going to combine the like terms by adding the coefficients and the constants. So just like every time when we see this kind of a problem, we're going to underline and circle the like terms. Let's underline the first one. Is there anything that's in the same family as the n family class? Everybody underline negative 10n. Now the last one is not in the n family, so we're just going to circle it. And remember, we're going to circle it with the sign that comes in front of it. Because if you remember the saying, every number has a sign, and that sign is directly in front of that number. Now what we are going to do is to focus just on the n family. The variable term will always come first. Remember, the variable term is the term that has a letter in it. When you see, let's focus on just the coefficient. Let's focus on the number part of that variable term. 6 and negative 10. Same sign or different sign?
Different sign.
Same sign, add and keep, different sign, subtract, okay? So we're going to subtract those two and then take the sign of the larger number.
Negative 4.
Negative 4. And what family was that in? So this is negative 4n. What about the last part? What should I do with that?
Drop it down.
Let's drop it down. Are these two in the same family?
No.
No. One has a variable and one is a constant. So some people will look at that and be like, oh, 4 and negative 4, I can cancel them out. You cannot cancel them out because they are in 2 totally separate families. So when it says simplify the expression, Isaac told us that means to make it more simple. You did. And that is how you find the answer. You don't have to do anything else other than that. Let's move on to problem B. We're going to do it the same exact way. Underline the first term. That's the y family. Is there anything else in the y family? Okay, and I heard Gavin just mention that it was a 1y. Slip that little 1 in there because that's going to help us as we add and subtract these together. What about the constant family? What numbers?
4 and 2.
Plus 4 and plus 2. Once again, you always want to put the variable term first. So we're going to start with our letter term. Notice this one right here is a negative, and these ones are positives. I want us to combine our positive ones first. So let's just focus on the positives right here. 6y plus 1y. What is that?
7y.
7y. Now, we're not going to write it down. I want us to start doing some stuff in our heads. So now I've got a 7y. Remember, the 7y comes from these being combined. And I have a negative 8y. Think about negative 8 and positive 7. What's the answer?
Negative 1y.
Negative 1y. Very good. And now I've got to bring down my constants, 4 and 2. Combine them together, and what do you get?
6.
Now, instead of just putting a 6, you always have to combine them by either adding or subtracting. So would it be plus 6? And that's your answer.
Wow.
Let's look at the next one. Jalen, help me find the like terms. What should I underline? Negative 4x? You're right. They are all in the x family, so I'm going to go ahead and just underline all of them. Now, do you guys remember how we talked about a number and its opposite?
Yes.
If I have negative 5 and positive 5, what does it equal? 0. If I have negative 10, positive 10, it equals? 0. Negative 30, positive 30, it equals? 0. So if I have negative 4x and positive 4x, guess what it equals?
8x.
0, because it's a number and it's opposite. So all I want you to do, take your pencil and just put one little line through it. They canceled each other out. Hayden, what am I left with? Just positive 8x. I'm going to drop that down, and that's my answer. That is what's wonderful about having numbers and their opposite, or variable terms and their opposite variable terms. Moving on to the next one. There's a plain old W by itself. How many plain old W's are there?
1.
So let's put that little 1 there. And notice they are all in the W family. So I'm going to combine all of them. As I just did previously, I want to combine my positive terms and my negative terms. Let's combine the positive terms. 5.2W plus 1. What is that?
5.3W.
All right, so I heard a lot of 5.3Ws. Watch this. If I have 5.2 and I add a 1, where's the decimal point on the 1? No, it's at the end. Can I do that?
No.
No, I have to line up those decimal points. So instead, what would that answer be?
6.2.
6.2. Be careful with that. Okay, so let's underline. We just did this part. That's 6.2W, not 5.3W. What should I bring, or what should I do with this? Let's go ahead and subtract it, and let's bring it down. Same sign or different sign? Same sign, add and keep, different sign, subtract. You can do this mentally. If you want, start with the tens place and erase, and get that answer. Start with the wholes place and get that answer. If you say, Miss Forpaw, I'm really bad at mental math, you can always come off to the side and do 8.5 minus 6.2. What's your answer?
2.3.
Take the sign of the larger number. Negative. And what family is this in?
W.
So your final answer is?
Negative 2.3W.
Excellent. For problem E, we have the B family. Let's underline. Both of them are in the same exact family. When I'm adding and subtracting a fraction, you always have to have a common
Denominator.
So let's just focus on the coefficients. Remind me again, what's a coefficient? The number part of a variable term. So I'm only taking the number part, 3/8 minus 3/4. Matthew, what's my common denominator? 8. So I've got to multiply by 2 on top and bottom. Let's just rewrite this underneath it. You might have to write kind of small. 3/8 minus, what does this equal now?
6/8.
6/8. Same sign or different sign? Okay, different signs, subtract and take the sign of the larger number. When you do that, what do you get?
Negative 2/8.
Negative 3/8. And what family is this in?
B.
So you've got to keep that B there. Remind me again, guys, when you have a number next to a letter, what do I do to those two?
Just
Is that add, subtract, multiply, or divide? That means to multiply. So this is negative 3/8 times B. Okay? Let's go on to the next one. Talila, will you underline the like terms for me? Okay, the negative 10y and the negative 5y. Those are in the same family, the y family. What should I do with the 15x, Talila? Good job. That's kind of by itself. Now what I'm going to do is combine my like terms. Let's combine the y family first. Negative 10y and negative 5y. Same sign or different sign?
Same sign.
Same sign. Add and keep. What is it?
15.
Negative 15y. And what do I do with the next part?
You bring it down.
Bring it down. Now look, I've got 15 and negative 15. Can I cross those out?
No.
Yes.
Because they're different families.
They are in different families. Listen, no matter how much I like Trenton, he's not in my family, okay? I might say, I want you in my family. He's not in my family. So there is no combining things. This is the Y family and the X family. They could be great friends, but they are not in the same family. So we just box it in. Do not try to combine numbers if they're attached to a letter. Think, pair, share. Let's try to come up with what our like terms are. Hope, what is like terms with the 7?
-5.
Excellent. Huang, what is like terms with the positive 3/4 p?
1P.
The 1p. Thank you for telling me a 1. I'm going to slip that 1 in there. Is anyone in the X family?
No.
Just that 2x. So let's just box it in. It's kind of by itself. This is what today's homework is going to look like. So you're going to write this as your original problem. Then I want you to write the word terms and write the word like terms on your notebook paper. What are the terms? Read it to me from left to right. The first one,
7.
the next one,
Positive over 4P. -5.
next one,
-5.
just the girls, next one,
1P.
1p, boys, last one,
2 plus 2x.
2x. Remember, the term, it's just the different parts of the expression that are being added or subtracted together. Now let's see if we can find the like terms. Trenton, what are the first like terms you see in our problem? Okay, start from left to right. Let's start with the 7. Is there anything like the 7? There is. 7 and -5. Brayden, is there anything else that is like terms? Excellent. 3/4 p and 1p. Now that 2x is by itself, so it is not like terms with anything else. Tonight when you have your homework, you're going to box in that answer like this. All right, I love what I saw as I walked around. Most people remembered to underline and circle the like terms. Now remember what I said. Variable term comes first. The variable is a what?
The number with
Nope. The variable is a letter. The letter. Always put the letters first and the constants at the end. So let's focus on the letters or the variables. What's 7p plus 4p?
11P.
11p. I want that part first. Now combine the constants. You get plus
8.
and that is your answer. Can I combine the p family and the constant family?
No.
No. If you switched the order and instead you put 8 plus 11p, please erase it and fix it. You always want to put the variable term first and the constant last. All right, so tonight's homework is 3.1. There are 10 problems, and I'm going to give you guys a few minutes to do it now. Remember, you need to submit it on Big Ideas and then also do it on paper.